Okay, so we're looking at question 4, part B now. What would you pay today for an investment that makes payments of $25 per year at the beginning of each year for the next 3 years at 7.2% compounded annually? So the only difference between 4A and 4B is that in 4A, the payments were at the end of the year, and in 4B, they're at the beginning of the year. And in terms of annuities, when we have the payment at the beginning of the year, it's referred to as an annuity due. So let's make a note of that because it's important to remember that. So if the payments are at the beginning of the time period, it's referred to as an annuity due. And if payments are at the end of the time period, it's referred to as an ordinary annuity. All of the ones we've done up to now were ordinary annuities, so they didn't really discuss the concept. But now that we've run into one that's at the beginning of the year, we have to make sure we understand what the concept is. In terms of where this is coming to you from in your textbook, this is in chapter 13. And the specific formula we're going to be using to try and solve this is called formula 13.2 on your formula sheet. And when you see the formula, you'll notice that it's incredibly similar to the formula we used in question 4.A, but there's one extra term added to accommodate the payment happening at the beginning of the time period. So I'm not going to try typing it. It'll be much easier to write it out so it'll look more sensible. So the formula here looks a lot like this. The present value equals the payment multiplied by 1 minus 1 plus I to the power of negative n divided by I, which is exactly the same formula we had for the ordinary annuity, but now we have to take into account the interest on one extra payment because it's made at the beginning of the time period. So we've got to multiply this by 1 plus I here. So it's exactly the same formula with this extra term to accommodate the payment at the beginning of the time period. So let's take a look at the numbers we're putting in here. What do we need to keep track of? They've given us the payment equals 25. They've told us the interest rate, I, equals 7.2%. And they've told us the number of compounding periods, in this case years, n equals 3. So let's plug those into this formula and see if we can make any sense out of it. So present value equals 25 outside of 1 minus 1 plus 7.2% to the bracket, or to the power of -3, all divided by another 7.2%, and then multiplied by 1 plus 7.2% again. So let's figure out how to get that into our calculator. Let's see what we're going to have to plug in here. I'm going to start with 7.2, hit the percent key, plus 1 equals. See what that is. Don't take it out of your calculator. Then y to the x 3, but it's got to be a -3, so we've got to hit the plus minus button. See what that is, but don't take it out of your calculator. Now we're going to have to take all that away from 1, which means we're going to make this negative again. So plus minus, and now we can go plus 1 equals. See what that is, but don't take it out of your calculator. All divided by 7.2% equals. Again, you can see what that is, but don't take it out of your calculator because you don't want to round it off. And now times, in brackets, 1 plus 7.2%, end of bracket, equals. And now we can multiply this whole thing by 25 and see what that equals. And I end up getting a number that looks like this, 70.075464624. But we're dealing with money here, so we only want 2 decimals. So 70.08 by the looks of it. And again, although it's important to know how to use the actual formula, and we can see they're getting uglier as we go, we also want to be able to use Microsoft Excel. So let's go over to Excel and see if we get the same answer. So what can we do here? Get rid of my smiling face. There's Excel. We've saved this, so we'll use it. And we're looking for the present value. So we have a present value here and here. We may as well use this one. Doesn't make any diff. We'll copy it over here. And we'll make it B. And what do we know here? We know that the rate was still 7.2%. We know that the number of periods is 3. We know the payment is 25. We know the future value has to be set at 0. And because the 0 here for future value represents the fact that at the end of the payments, there's no money left in the bank. But the type here should be a 1. And lo and behold, Excel now, incredibly enough, comes up with exactly the same answer. So the only difference between 4A and 4B as far as Excel is concerned is type is 0 for ordinary annuity. So we can label that so we can remember. And this one where type is 1 is annuity due. So good to keep track of what the difference between the two of them is. Let's shrink this up a bit because we're running out of space. Oops, let's go. Try that again. There we go. So, and let's remember to save that because we don't want to have to reinvent the wheel every time. So let's take this back and compare it. Text, Control V, and we get exactly the same answer. Although the cash flow concept, this says the present value is negative because that's how much we have to put into the investment in order to get $25 per year out of this investment. And the reason this one is a slightly higher amount is because we're getting the payments earlier than before, because the payments are at the beginning of the period. So hopefully that made perfect sense. And hopefully you'll be able to do those calculations with the homework that you have. So stop recording.